Ever get that feeling? Like you're watching AI video analyzers and they're just not really getting it.
I'm really getting a how.
Like they're catching the highlights but kind of missing the point. It's like when you skim a book, you get the basic idea, but all the nuance is gone.
Ah, I see what you're saying.
Right. And it's not just about like missing a funny cat video moment. This whole struggle AI has with longer videos has some pretty big implications.
Oh, absolutely.
Which is why we're diving into this research paper today called Interpolating Video-LLMs Toward Longer Sequence LLMs in a Training-Free Manner.
Catchy title.
Right, I know. Bit of a mouthful, but trust me, it's got the key to a major AI unlock if we can, wrap our heads around it.
It really does. This paper goes right at a huge problem, the short attention span of most AI when it tries to understand video. They're stuck in like a TikTok world. Meanwhile, we're living in full-on documentaries.
Okay, but it's not that AI is just being lazy, right? There's a real technical reason they hit this wall.
It's like those videos too long, didn't watch memes, but it's the AI that's hitting that wall. This paper uses Video-LLM as the main example, and, it's leading-edge stuff, but even it can only handle about 8 frames per video on average.
8 frames? That's like trying to understand a movie by glimpsing at the screen 8 times.
Right. And think about all the places we're trying to get AI to watch and understand things for us. Security footage, sports analysis, even just figuring out what movies we'd actually enjoy.
I mean, if AI can't grasp the full context of a video that's longer than a few seconds, its analysis is going to be so limited, right?
Totally. And it means its usefulness in those real-world applications, the stuff that actually affects our lives, that it all takes a nosedive.
So what have researchers been trying so far? There have to be workarounds.
There are some clever ones out there. For example, you've got models like ChatGpt trying to cleverly merge spatial and temporal data, like piecing together a puzzle while also knowing when each piece was put down.
Interesting.
And then there's Llama Vid, which uses this dual token system, kind of like a secret code for video data, to help make it more manageable for the AI.
So smart approaches, but not without their drawbacks.
The biggest one is they all need more training for the AI, which means more data, obviously, to learn from, more time to do the training, and here's the kicker: more computing power.
And we all know what more computing power equals.
More money. So it becomes this really expensive process, which just makes these solutions less accessible.
So not exactly ideal for anyone without deep pockets, right?
Yeah, it can be a real barrier.
But this is where INTP comes in, right? Like, it's the key to making this whole video understanding thing work without needing massive amounts of training data.
Exactly. INTP, which stands for interpolation, is all about getting AI to work smarter, not harder.
Okay, I like the sound of that. So how does it actually do that?
Well, there are 2 main innovations they introduced. The first one is called alternative video token rearrangement.
Alternative video token rearrangement. Okay, I'm going to need you to break that down for me.
Laughing. Sure. Think of it like this. You're putting together a jigsaw puzzle, right? But you can only see a few pieces at a time. INTP is like rearranging those puzzle pieces to help you see the bigger picture.
I see. So instead of being overwhelmed by the whole puzzle at once, it lets you focus on smaller sections and then figure out how it all fits together.
Exactly. And in this case, those puzzle pieces are the video frames. By rearranging them, INTP allows the AI to extract the maximum amount of information from a limited number of frames.
So it's sort of tricking the system in a way, right?
You could say that. It's about finding clever ways to work around the limitations of traditional video processing methods.
Gotcha. So that's the first innovation. What about the second one?
That one is all about memory. It's called Interpolating Video-LLM Backbone, and it's essentially a way to expand the AI's memory or its context window.
Context window, like giving the AI a bigger hard drive.
Kind of. Imagine you're trying to take notes while watching a movie. With a small sticky note, you can only jot down a few key points, right? But with a whiteboard, you can capture much more detail. INTP is like giving the AI a much bigger whiteboard.
Aha! So it can hold more information in its mind at once.
Exactly. This allows INTP to maintain a much better understanding of what's happening in the video, even as the action unfolds over a longer period of time.
Okay, I'm starting to see how this all comes together. By rearranging frames and expanding the AI's memory, INTP is essentially allowing it to process and understand much longer videos without needing to be retrained on massive data sets.
You got it. And that's a game changer because it removes one of the biggest barriers to entry for anyone who wants to explore AI video analysis.
I bet. No more needing those Google-sized budgets just to get started.
Exactly. It really democratizes the technology.
This is all sounding pretty amazing, but, and I know there's always a but, AI isn't exactly known for being lightweight, right?
That's a valid concern. Asking AI to do more thinking requires more resources. And the paper does acknowledge that there are some practical considerations.
Like what? What kind of bottlenecks are we talking about here?
Well, they found that the KV cache was a major constraint.
The what now?
Sorry, more jargon. Basically, the KV cache is like the AI's short-term memory, where it stores its work while analyzing the video. The more frames you feed in, the more space it needs.
Kind of like when I have too many tabs open on my computer and it starts to slow to a crawl.
Precisely.
So they identified this memory bottleneck. Did they figure out a way around it?
They did. They actually came up with a pretty ingenious solution called post-training quantization.
Post-training quantization. Okay, you're going to have to break that one down for me.
It's actually simpler than it sounds. Imagine you have a really detailed picture, and you need to send it to someone, but the file's too big, so you have to compress it.
Right, make the file size smaller.
Exactly. And that's essentially what quantization does. It reduces the amount of data without losing the essential information, like shrinking a file before you email it so that it doesn't clog up their inbox.
Okay, so we're making the information more manageable for the AI to process.
Precisely. And this quantization process allows INTP to handle that increased workload from all those extra frames and expanded memory without getting bogged down.
Okay, so far so good. INTP sounds great in theory, but does it actually work? Did they put it to the test?
They did. They ran INTP through a whole battery of industry standard benchmarks. MSVD QA, ActivityNet QA. Think of it like the AI equivalent of taking the SATs.
So a real test of its abilities, and
How did it do?
INTP consistently outperformed the standard Video-LLM. And not just by a little bit, we're talking significant improvements in its ability to answer complex questions about the videos.
That's huge. So
Yeah.
it's not just understanding what it's seeing, it's actually able to interpret and analyze it on a deeper level.
Right. It's not just identifying objects anymore. It's understanding the context, the storyline, the nuances of what's happening in the video. And remember, all of this without any additional training.
Which is incredible. I have to admit, when I first heard about this paper, I was a little skeptical. But seeing those results really drives home how much potential this has. It's definitely exciting. This isn't just about tweaking algorithms. It's about fundamentally changing how AI interacts with and understands the world around us.
So let's talk big picture for a minute. What kind of impact could INTP have on our everyday lives?
Well, think about all the areas where video analysis is crucial. Medical diagnoses, security systems, self-driving cars. INTP could make all of these things significantly more accurate and reliable.
It's like we're on the cusp of this new AI-powered era. But like with any new technology, there are always potential downsides, right?
Of course. And the researchers do acknowledge that. They have a whole section in the paper dedicated to societal impacts, where they really dig into the potential risks as well as the benefits.
Like what kind of risks are we talking about?
Well, for example, INTP could potentially make it easier to create those deepfakes, those hyper-realistic fake videos that are becoming increasingly difficult to detect.
That's a good point. It's a reminder that as we develop these incredibly powerful technologies, we also need to think about the ethical implications and make sure they're being used responsibly.
Exactly. It's a conversation that we need to be having as a society.
Absolutely. Well, on that note, I think we've covered a lot of ground today. This has been a fascinating deep dive into the world of INTP and the future of AI video understanding.
It certainly has.
Mhm.
And it's just a glimpse of what's to come in this rapidly evolving field.
For our listeners who want to learn more about INTP, be sure to check out the full research paper. We'll link it in the show notes. And as always, thanks for joining us on the deep dive. Until next time, keep exploring and keep asking those important questions.